Welcome to part 6 of the recursion video series. In today's video, we'll look at how to solve Leetcode problem 46 called permutations. So in this problem, they'll give you an array of distinct integers and you have to print it in every possible order. So if your input is 1, 2, 3, you can print it as 1, 2, 3, 1, 3, 2, 2, 1, 3 and all these ways. So it's important to note here that these numbers are distinct. If the repeating numbers, there is a slight modification to the strategy. This will work if the numbers are distinct. So first let us think, if you are solving it with a pen and paper, no computers, just pen and paper, how would you solve it? So if you have your input, say 1, 2, 3, you can pick the first number in 3 ways. You can pick it as 1 or 2 or 3. Once you pick the first number as 1, you can pick the next number 2 or next number 3. Once you pick the next number 2, the only way to pick the next number, last number is 3. Similarly, once you pick the second number as 3, the only way to pick the last number is 2. Now what if I had selected 2 as my first number? If I pick 2 as my first number, I can either pick the next number as 1 or next number as 3. If I pick the next number 1, the next number can be 3. If I pick the next number as 3, the next number can be 1. So what we are observing here is what I had told you about when to use recursive problems. You use recursive problems if you are solving the same problem again and again with different inputs. So here, if you think of it like this, okay, this is a chosen list, there is a remaining list. Every single stack frame, which is a method call, what I'm doing is I'm picking one number from the remaining and putting it into chosen. And I'm doing that in every possible way. So if you remember, I had told you in the initial videos that every stack frame is another call to the method. Every stack frame, we solve one small part of the problem and hand over the next to the next problem. So in this stack frame, what I'm going to do, the very first call to this method, I'm going to pick 1 as the chosen, call it to the next method. Okay, so I've done one part here where I picked 1 as the first number. Then I pick 2 as the next first number, call the next stack frame. Pick 3 as the first number, call the next stack frame. So in this particular stack frame, I'm choosing the first digit only in every possible way. So that's all this guy does. He picks the first number in every possible way. Once the call comes here, okay, this stack frame gets a chosen list and a remaining list. Now what this guy is going to do is again pick the second number in every possible way, which is 2 and 3. So he'll pick 2, call the next stack frame, pick 3, call the next stack frame. So now we see that repeating pattern, right, where you're taking one number from the remaining and putting it as your next number in every possible way. So that is the pattern, repeating pattern, because of which we can use recursion, because the same problem again and again. The only thing changing is what is in chosen and what is in remaining. This guy is doing the exact same thing as this guy. Only thing different for him is these two lists are different, but what he's doing the same thing. So now that we've proven it's a recursion problem because we are doing the same thing again and again, next question is what is the base case? Because recursion ends at the base case. So in this case, the base case is where there is nothing left to choose from. The remaining is empty. When your remaining is empty, you hit the base case. So then you print out that. Here remaining is empty, you print out that. So now we've looked at why this is a recursive problem. Now the next part is this is a backtracking problem. Now why is it called a backtracking problem, right? So it is recursion, we already know that, but what is additional here to call it a backtracking problem? So the answer to that is, when I call from here to here, right, I can call where I create a new list for this one, new list for this one, okay? I can again, when I call from here, I can create a new list for this, new list for this. Instead of modifying the same list and passing, I can create a new list and pass that to every call. That will work. In that case, it's not a backtracking problem. It is a backtracking problem because what we do is we don't create new lists for every stack frame because that's a very inefficient solution. What we instead do is we have two lists in the beginning. One is a chosen list, one is a remaining list. and we keep modifying those same two lists. If you don't understand that part, I would encourage you to watch my first two videos, which are very short, where I explain the difference between primitive and reference type. So if it's a reference type, the same object is visible to all the stack frames. So what we do instead is from here, I create two, so the problem passes in an array, but I convert that to a list because then the code becomes simpler. It's there in the description, you can play around with it on Leetcode. So if you have two lists, one for chosen, one for remaining, what I do is I take one from here, put it in chosen, make a call. Okay, it will do whatever it has, it will come back here. I take that one and I put it back because I want the original state. Then I take two, put it here, make the next call. It finishes all this, comes back here. Then I take two from here, put it back here in the same position as number. So if I take it from second position, I'll put it back into second position or the first index. Same three, I take it, put it here, do call that method, finishes everything. In this case, you don't need to backtrack because it's code will end, but you won't write a special case that if it's a last element, don't backtrack. So your code will always backtrack. But the way to think of a backtracking problem is like this. Choose, explore, unchoose. And this is again, if you have reference type. If you have primitive types, it won't be this way. In reference types, they are visible to all the stack frames. So you undo whatever you did before you make the next branch in your decision tree. So when I come here, I'll take this stack frame. This stack frame will take two, put it here. We call the method again, which is another stack frame. It will finish all that. The code will come back to this stack frame. It will take two, put it back here in this position, the first position. Then take three, put it here. Call this, comes back here. You put it back here. And then when this comes back here, this guy will take the one and put it back here. So this is pretty much why it's a backtracking problem. So another thing I wanted to talk about here is when you reach this part, the last part where you have to copy this into your final list. So you have to return a list in Leetcode. So when you copy, you should not do whatever, say your list name is result list. You should not do result list.add chosen because, like I said, it's a reference type. So whatever change you make in any stack frame is visible everywhere. So if you do result list.add chosen, at this point it will be correct. But when it comes here and it does backtracking, it is going to affect your result also. So what you need to do is you copy this into a new list and put that list into your result. So let's see, anything else? Yeah, so now last thing I wanted to talk about here is how to think of it in terms of stack frames. So if you watch my first videos, I go extensively into stack frames. So every call to the method is a new stack frame. That's the easiest way to think of in recursion. So when the first call comes, it's a stack frame here. I take one and put it here and I make the next call to the same method. That's a new stack frame here. And then once it comes here, what it will do, it will take the next number, put it here, make another call, which will be another stack frame here. So the way the code is gonna execute, it's not gonna be like this, like this, like this. The way it's gonna execute for a single threaded program, it is from here, it will come here. From here, it will come here. From here, it will come here, come back here, then it will come here, then it will come here, come back here, come back here, come here. Then the next call is made here, it will come here, it will come here, come back here, come back here, come back here. So this is why if you write the code, if your input is the same and if you write the code the way I wrote it, the output will be exactly in this order. You'll have 1, 2, 3, 1, 3, 2, 2, 1, 3 and in this order. It will be in this order for the reason that the way stack frames work. From here it will come explore all of this, come back here, explore all of this, come back here, explore all of this, come back till here, come explore all of this, come back here, and like this. So that's all I needed to cover in today's video. I'll be covering a few more backtracking problems going forward. Thank you.